Hello friends, welcome in a lecture of Mechanics of Solid Subject. Myself, Mitesh Patel. I am a assistant professor in a mechanical department at a Dr. Subhash Technical Campus, Junagadh. Today's lecture topic is a moment of inertia. Uh, this is the third lecture of moment of inertia. So in this lecture, we solve the examples related to moment of inertia. In last two lectures, we already discussed about what is the moment of inertia, what is the mass moment of inertia, area moment of inertia, and how do we find out the moment of inertia of regular shapes and equations of different kinds of regular shapes of moment of inertia, parallel axis theorem, perpendicular axis theorem, and we solve the one examples of moment of inertia. So in this lecture we elaborate the more examples or solve the more examples of moment of inertia. So let's start the lecture. Okay, so all these things we already discussed that in last two lectures. Okay, T section examples we already discussed. Now see the I section examples. Now we have to find out the Ixx and Iyy for symmetrical I section with flange 100 into 10 mm thick, 100 mm wide and 10 mm thick, web 280 mm deep and 100 mm 10 mm thick. Okay, so now you know that we have to find out the Ixx Iyy means moment of inertia about x axis and y axis which are passing through the CG of this total section. Okay, so first what we have to do, first we have to find the position of x axis and y axis which are passing from the CG. So first we have to find out the CG to place the x and y axis which are passing from the CG. So first we have to find out the CG, and here first we have to see that for to find out the CG, section is symmetrical or not. Section is symmetrical for both axes, so we can directly find out the CG. X bar and y bar value we can directly get the half of the total of x and y dimension. Okay, so because I section is symmetrical about the y axis, if we consider this y axis, then both left and right side part are equal, and similarly from we see that from the x axis we can see the this two portions are perfectly similar, so it's symmetric about the x and y axis. So directly we can get the CG value. X bar directly get half of the x dimensions, 100 half 50 mm x bar, and y bar is a half of the vertical distance. It's 280 plus 10 means the 280 plus 20, so 300 by 2, 150 mm is a y bar. Okay, so x bar and y bar we calculate that easily. Now we have a CG. Now place the x and y axis according to y bar and x bar. Okay, so x axis is placed at a y bar from the this corner of y. Okay, from vertical distance 150 mm, and from this point x bar at x bar distance CG is there, and from that x axis and y axis is generated. So from this corner x bar is a 50 mm and y bar is a 150 mm. Okay, now we know that how to find out the moment of inertia of compound section. We first find out the moment of inertia of each individual element, and after that summation of the all elements moment of inertia, and find out the total moment of inertia. So first we have to find out the moment of inertia of individual elements of these three elements. Now first we find out the Ixx, means moment of inertia about x axis. So let's this Ixx1, so moment of inertia for element 1 about this x axis. Okay, so according to parallel axis theorem, Ig, what is this? What is the Ig? Ig is the moment of inertia about a given area of CG. એટલે કે જે એરિયાનું મોમેન્ટ ઓફ ઇનર્શિયા ફાઇન્ડ આઉટ કરવાનું છે એ એલિમેન્ટના એટલે કે એ એરિયાનો સીજીથી મોમેન્ટ ઓફ ઇનર્શિયા એટલે કે આઈજી. હવે આઈજીનું તો ઇક્વેશન ડાયરેક્ટલી છે બીડી ક્યુબ બાય 12, એટલે કે આઈજી ડાયરેક્ટલી equation through we can get, but we have to find out the moment of inertia of this first element about x axis. So we have to use the parallel axis theorem, Ig plus area into distance square. Okay, so area of this element is a 100 into 10,000 mm square, and distance h is this distance of CG of first element from x axis. Okay, so how it's the total distance of this is a 300 of 150. Sorry, here is a 150, y bar is a 150. Okay, y bar is a 150, and this total distance is a 150, but CG is counted, so 5 is left, so CG is at a distance of 5 from upper edge, so total distance is 45. 5 plus half of 280 is a 140 plus 5, so 145 h. Okay, h1. Okay, h1 is a 145, half of 280 is a 140, total distance this is a 140, and half of this 10 is a 5. Okay, so 5 plus 140 is a 145, so h1 is the 145 square. Okay, and bd cube by 12, breadth b 100 mm and depth is a 10 mm, so bd cube 10 raised to cube upon 12, and we get the value through this equation, and this value Ixx1 value is a 21.03 into 10 raised to 6 mm raised to 4. Okay, now we get the moment of inertia for a second element about this x axis. Okay, so first of all we have to find out the Ig for element 2. It's a bd cube, so breadth is a 10 and d is a 280, so 280 cube and into 10 by 12, and now a into h square. Now the CG of second element and CG of this I section is coincide, એટલે કે એક જ છે, બે એક જ પોઈન્ટ ઉપર છે, સેકન્ડ એલિમેન્ટનું સીજી અને ટોટલ આઈ સેક્શનનું સીજી. બરાબર છે, તો એલિમેન્ટના સીજીથી એક્સ એક્સિસ સુધીનું ડિસ્ટન્સ શું થશે? તો કે 0, કારણ કે એક્સ એક્સિસ ક્યાં આવેલી છે? તો કે આઈ સેક્શનના સીજી ઉપર. તો એક્સ એક્સિસ આઈ સેક્શનના સીજી ઉપર છે, અને આઈ સેક્શનનું સીજી અને એલિમેન્ટનું સીજી એક જ છે, તો એચ કેટલું આવશે? 0. સો એચ ઇઝ 0, સો એચ સ્ક્વેર એ ટોટલ ટર્મ છે એ 0 થઈ જશે. સો ઓનલી આઈજી ઇઝ ધેર, એન્ડ આપણને મળી જશે Ixx2 ની વેલ્યુ 18.229 into 10 raised to 6. બરાબર? ઓકે, નાવ Ixx3 એટલે કે થર્ડ એલિમેન્ટ માટે મોમેન્ટ ઓફ ઇનર્શિયા ફાઇન્ડ આઉટ કરવાનું છે. ક્યાંથી? ફ્રોમ વેર? ફ્રોમ x axis. Okay, so first of all we have to find out the Ig, moment of inertia about moment of inertia of third element about its CG, એટલે કે એના CG થી એનું moment of inertia Ig. What is that? bd cube, breadth is a 100 and depth is a 10. Okay, So b d cube, d is a 10 cube by 12, 100 into 10 cube upon 12. Now area 100 into 10,000. H distance total is a 150, but 5 is minus because the CG of this element is at a middle of 10. Okay, so from that this distance is a 150 minus 5, so 145. Okay, so h square is a 145 square, and we usually get the value of Ixx3 21.03 into 10 raised to 6 mm raised to 4. Okay, now total moment of inertia of this I section about this Ix axis is get through the summation of all moment of inertia of these all three elements. So we sum that, we summation that of all elements moment of inertia and get the total moment of inertia of this I section is a 60 into 35 into 10 raised to 6 mm raised to 4. Okay, similarly we have to find out the moment of inertia for y axis. Okay, we have calculated the moment of inertia about x axis. So now we have to find out the moment of inertia about y axis. So similar procedure is that for that first find the moment of inertia of first element about this y axis, but CG of first element and CG vertical axis is passing from the CG of I section, and vertical axis of or we can say that CG of this element and vertical axis of CG of I section is in same axis. So distance is a 0, h is 0. એટલે કે y ડાયરેક્શન એટલે કે y એક્સિસ માટે આઈનું સીજી ફર્સ્ટ એલિમેન્ટનું સીજી અને y એક્સિસ સુધીનું ડિસ્ટન્સ કેટલું છે 0. સો h is 0 here. Okay, so h is 0, that's why h square term is a 0, so only ig is there for iy1. So ig is a, we know that now Iyy is there, so equation becomes db cube by 12. So depth is a 10, d and b is a breadth 100 mm, so 100 cube by 12. For I axis bd cube by 12, and for yy db cube by 12. Okay, remember that. Here the term is 0, so h square term is 0, so only ig is there, and we can get the value of iy1 for first element 8.33 into 10 raised to 5. Okay, 1 minute. Okay, iy1 iy2. Now iy2 for means the moment of inertia of element 2 about y axis. Similarly here h is 0 because element 2 CG of element 2 and distance of y axis which are passing from the CG of I section, distance between the y axis and CG of the second element is 0, so h is 0, so h square is 0. એટલે કે બીજા એલિમેન્ટનું CG થી વર્ટિકલ y સેક્શનનું y એક્સિસનું જે I સેક્શનની વર્ટિકલ એક્સિસ છે y એક્સિસ ત્યાંથી સેકન્ડ એલિમેન્ટના CGનું ડિસ્ટન્સ 0, so h is 0, so h square term is 0, so only ig is there. So for Iyy db cube by 12, depth is a 280 and breadth is a 10 cube upon 12, and this term is 0. So I/2 is a 0.233 into 10 raised to 5 mm raised to 4. Okay. Now for the third element, Ig dB cube by 12. So depth is a 10 and breadth is a 100. So 10 into 10 100 raised to cube upon 100 cube upon 12 plus area to 1000. Area is 1000 and h is also 0 because the CG of this element is in middle and it's passed from the y-axis. So distance between the y-axis and CG of element is 0, so h is 0, so h square term 0, so only Ig is there. So find out the value of I by 3 for third element. Moment of inertia of third element about y-axis is 8.33 into 10 raised to 5. Now the total moment of inertia of this I section about y-axis is the summation of all element moment of inertia about y-axis. Okay, so we summation of all moment of inertia of all elements, and finally we get the value of total moment of inertia of this I section about y-axis is a 16.893 into 10 raised to 5 mm raised to 4. So through polar axis theorem we can get the moment of inertia of composite area, given composite area of any section, any elements generate from the any elements, we can easily find out the moment of inertia. Okay, let's see the another example. It's a L section. Okay, two elements are there, both are rectangles. Okay, so what we have to find out, we have to calculate the I-axis and I by y, and for unequal angle section, 125 into 75 into 10, into 75 into thickness is a 10. Okay, as shown in figure is given. Now what we have to do first, you all know that now you all know that first step to find out the I-axis and y is a find out of CG. So for find out the CG, we can see that if the object is or a given area is symmetrical or not, but it's not symmetrical about any axis or y-axis. So we have to find out the x bar and y bar with these equations of x bar and y bar equations. So first we have to find out the area of first element, and x1 of first element, and area of second element, and x2 of second element. Okay, so area of first element is a 10 into 115 mm. Okay, so 150 mm square is the area, 150 mm square. Okay, now x1 is a distance of horizontal axis to the CG of first element. CG of first element is a half of 115 plus this distance 10. Okay, so 67.5 mm y1. Okay, now for part 2, area 75 into 10, area is the 750 mm square. Now x2 is a CG of second element to the reference axis is at base, so distance is half of 10, 5. x2 is a here now part 1 is the consider is a invert that invert that. This is a part 1 is count, and sorry, this x1 and x2 is inverted. આ x1 અહીંયા આવશે અને આ x2 અહીંયા આવશે. Sorry, this is okay. x1 is find out, so x1 is find out, it's a half of 75, it's a 37.5, and y2 is a 5, sorry, y2 is a 5 and x2 is a 75 by 2. Okay, sorry for that. Now x bar and y bar equation having a all values a1 x1 a2 x2 a1 plus a2. Now put the all values and get the x bar value is a 17.82 mm and y bar value is a 42.82 mm. Okay, so now here have a value of x bar and y bar, so we get the position of CG about at this reference point. It's at a x bar distance 17.82 mm and at a vertical distance 42.82 mm. So we can place the CG, and about that two axes passes, xx and yy axis, and now we have a position of xx axis and yy axis according to dimension of section L section. Okay, now we have to find out the moment of inertia about xx axis and yy axis. For that we have to find out the moment of inertia of individual element 1 and 2 about xx axis. Okay, so let's consider the first element. For I axis 1, Ig of this first element is a BD cube by 12. So breadth is a 10 and D is a depth is a 115 mm. So 115 BD cube, D is a 115 cube upon 12. Now area is the 150 into 10, 1150 area. Now H is a H we have to find out. This CG of this first element is at here and the x-axis is here, so this distance we have to find out. We define as a h1, so h1 we have to find out. Now first total distance, this total distance is what? It's a half of 115 is a 57.5 57.5 plus 10 means 67.5. okay, 67.5. so the total CG distance from the base is a 67.5 and total y bar distance is 42.82. so 60 from 67.5 42.82 is minus, then we can get the value of this h1. okay, so 67.5 minus 42.82. okay, so put the all values and we calculate the value of ixx1. okay, so it's a 1.96 into 10 raised to 6 mm raised to 4. okay, now moment of inertia for second element. So what is the Ig? BD cube by 12. Breadth is a 75, so 75. D is a 10 raised to cube upon 12. Now area is a 75 into 10, 750 mm square. Now the value of H. Now from x-axis, distance from x-axis to CG of element 2. What is the distance? It's a 48.82 minus 5 is a h2. એટલે કે આ એલિમેન્ટના CG થી x એક્સિસ સુધીનું ડિસ્ટન્સ કેટલું થશે? તો કે અહીંથી 5 માઇનસ થશે ટોટલમાંથી. ટોટલ કેટલું છે? 42.82 માઇનસ 5. બરાબર છે? Now we can easily get the value of I axis to 1.08 into 10 raised to 6 mm raised to 4. Okay. Now we know that now the total moment of inertia of this L section is find out with the summation of I axis 1 and I axis 2, and let's get the summation and finally get the value of total moment of inertia of this L section about x axis is 3.04 into 10 raised to 6 into means mm4. Unit is a mm4. Okay. Now go for the moment of inertia about y axis. Okay. So similar procedure, polar axis theorem is applied. For first element we have to find out the moment of inertia about y axis. So here what is the first Ig? Here dB cube by 12. What is the d? D is a 10. Sorry, d is depth is a 115 d. B is a breadth 10 mm, so 10 raised to cube by 12. Okay, Iyy is a dB cube by 12. Okay, and I axis is a bd cube by 12. Here is a dB cube by 12. Okay. Now area is a 1150. We know that 115 into 10. Now from CG of first element to y-axis distance we have to find out is a h or h1. Okay, what we have to notify that from h1 or h. Okay, now the total distance is a x bar is a 17.82 and distance of CG from this outermost edge is a 5. So 17.82 minus 5. Okay, so get the value of h means distance of y to CG of first element. Okay, clear? Now we have all values, so easily get the value of Iyy1 and it's a 1.98 into 10 raised to 5 mm raised to 4. Okay, now we have to find out the moment of inertia about y axis for second element. So use the polar axis theorem. So first of all Ig is a moment of inertia of center of gravity for second element. It's defined by dB cube by 12. What is the d? D is a depth is a 10 and b is a breadth 75 mm cube upon 12. So Ig is there. Now we have to value of h, find out CG of this second element. Distance h is find out is between the distance between the y axis and CG of second element. This is the h or h2. Okay, so CG distance from that is a total half of 75 is a 37.5 and the total x bar is a 17.82. so distance of CG of second element from this edge is a 37.5. This is now y axis distance from this base is a 17.82. so subtract the 17.82 from 37.5, then we get the value of distance between the CG of second element to y axis. So 37.5 minus 17.82. Okay, and now we have all values of Iyy square, Iyy2. So now we easily get the value of moment of inertia about y axis for second element. It's a 6.42 into 10 raised to 5 mm raised to 4. Now we know that for a total moment of inertia about y axis what we have to do? We have to summations of the moment of inertia of y axis of all elements. So summation it of Iy1 and Iy2 and get the total value is a 8.4 into 10 raised to 5 mm raised to 4, which is the total moment of inertia of this L section about y axis. So I hope that you very well understand how to find out the moment of inertia about x axis and y axis with the help of parallel axis theorem. So what is the first step? The solution of this example is convert into the easy step and memorize it. So you can easily solve this moment of inertia examples, this kind of. So what is the first step to solve the example is find out the CG, then after place the x axis and y axis in figure and define the x bar and y bar, and then find out the moment of inertia for xx and yy for individual elements ixs1, ixs2, whatever the number of elements, given elements, and now summation of it and ixs is get. Now for same procedure is applied for the y axis and you get the moment of inertia. I hope that you very well understand all things related to moment of inertia and its examples, how to find out the moment of inertia with the help of parallel axis theorem. Thank you for listening lecture.